Here I have a unit circle, which means it has a radius of 1, centered on the origin. Now I'm going to take a piece of red string. This length of string I'm going to wrap around the unit circle, so it will form an arc, like this. And that arc will end up at a point P. So as I vary my length T, I'll vary my point P around the circle. Let's keep increasing the length and see what happens to P. There we go, that's no great surprise. The longer the piece of string, the further around the circle it gets. Now, this point, well, let's get a point actually. This point P forms an angle that we are going to get very interested in. And you already know quite a lot about this angle. For example, if I get the length to, the arc length is 1, so my piece of string is 1 unit long. I wrap it round the circle so that the arc length has to be the same. It's the same piece of string. So that arc length is 1. The radius we know is 1. And therefore, what's the angle? When the arc length equals the radius, you know from the work we've just been doing that that angle must be 1 radian. Okay, what happens if I go to 3.14? Well, why would I go to 3.14? Of course, that's about pi. Where is pi? Where will an arc length, a piece of string 3.14 long, where will that end up with point P on the circle? Let's have a look. Okay, that's as close as I can get, 3.12. There we go. If I could get exactly pi, 3.14 and a bit more, then my point P would be exactly on the x-axis, wouldn't it? And that would mean I had an angle of pi, or in the old language, 180 degrees. Now, there's something very important about this. Oops. About this point P that we get as we wrap around. So I take any length T dash here, I wrap it around, so I can call this the wrapping machine, and I end up at a point P. What do you know about that point P? There's only one P for any length T, or T dash. Any length, given length, so 0.7 I've got at the moment, that only ends up at 1 point on the circle, doesn't it? It ends up right there. There's no option. In other words, for each input, T, there's only one output, P. So this wrapping thing is actually a function. There's only one output for every input. So let's give it a special name. We'll call this the wrapping function. That's the function that takes my length of string T, or T dash here, and turns it into a point P on the unit circle. That's a unit function. That is a function. Now I want to look what happens when the length of the string T dash keeps getting bigger and bigger and bigger and just keeps growing and growing. We keep wrapping that around the unit circle. What do you think will happen? Well, let's have a look. Let's first zoom out a little bit. Okay, we've zoomed out so that we can watch this T, this length of string, red string, growing and growing, and then see it wrapping itself around the circle. Just watch what happens, because there's something very interesting and very important. Okay, ready to go. So now we'll watch as the length of string grows and wraps around the circle. Here we go. And now we're getting to somewhere very interesting. What happens when the length is 6.3? That's about 2 pi. Because 2 pi, you know, is one full circle. Well, let's have a look. We'll see if we can get to 6.3 or close to it. And look, the string keeps going. Of course, it can go on forever. But what happens to our function, our point P on the circle? It just repeats itself, doesn't it? Goes back to where it's been before. Okay, so what about, so that's what happened when we got to 6.3. What about 12.6? Is the same thing going to happen? Let's have a look. And sure enough, around it goes again. So we can send t off to infinity, and our output, the point P, is just going to go round and round and round and round and round as many times as it has to, and still end up nicely somewhere on our unit circle. Now, this type of function is given a special name. It's called periodic when it repeats itself like this. And the period is the time it takes to repeat itself. So the period here, how long before it went and did the same thing again? It was 2 pi, wasn't it? So it takes 2 pi to get once around, and then it repeats itself. Another and important way of saying that is that we can take any value at all of t, and if we add and look at the output, so let's do that. Let's go back a bit though. Okay, the 2.6 will do us. Doesn't matter, it can be any value. So our t is 2.6. Now if we add 2 pi to that, we look at where the output is now. In other words, where is point P now? It's here. If we add 2 pi, I'm predicting that because 2 pi is the period, we will get exactly back to the same point. Well, you keep a check on that as I add 2 pi to this 2.6. So 2 pi is 6.3. I need to get to 8.9. You watch P and see if it comes back to the same place it's at now. Here I go to 8.9, 8.1, 2, 6, 7. Okay, it's in between those two. But there you can see, adding 2 pi to t, the input, gives us the same output. That's what we mean by periodic. And that's what we mean by the period. It's the amount that we add on, and it has no effect. It gives us the same thing. And that's very important. Okay, so now we've zoomed back in and we come to possibly the most important part of this video. Each point P that ends up on the circle will of course have x and y coordinates. So let's put them on. And these x and y coordinates of course change as P changes its position on the circle. And what causes that? The length of our red string t. So let's change t, and we see x and y changing too, of course. Okay, so the values of x and the value of y, they both depend on t. In other words, we've now got two functions we can look at. The one that gives us the x coordinate, x, when we put in t, and the one that gives us as output the y coordinate when we put in t. These are two quite different functions. Now, they are actually incredibly important functions, and they're so important we give them names. We call the x coordinate of P, when the arc length is t, we call that cosine of t. The input is t, the function is cos, the output is the x coordinate 0.68. The y coordinate we call sine t. Again, the function sine of the input t, the arc length, sine of t is the y coordinate of the point P, 0.73. So on the unit circle, x equals cos t, y equals sine t. That's really important. Now, you can tell me straight away with this knowledge what the cosine of pi is. Maybe you don't know that you can do it, but you can. Because where is pi? Well, 3.14. There we go, close as I can get. If I was exactly at pi, of course, p would be on the x-axis. Okay. Now, look at p down on the x-axis. What's its x coordinate here? Here's the origin. is 0. The x-coordinate of this point when it's here is -1. So if t is pi, if our arc length, our length of the string was pi, then cos of pi is -1. You can check that on your calculator. But you're right, you don't need a calculator for many of these things now. While we're here, let's do sine of pi. Well, what's the y-coordinate? Here's the y-axis, the x-axis, and of course the point P is on the is on the x-axis, so y is 0. So cos of pi, -1, sine of pi, 0. Let's do another one. Let's do pi by 2. Back we go, get as close as we can. There. Again, that's, if I had to find a scale, that would be perfectly vertical. And so the x-coordinate of pi by 2, which in the old language was 90 degrees, cos of pi by 2, what's the x-coordinate of this point now? It hasn't got any. There's no x at all. So cos pi by 2 is 0. And what's the y-coordinate? It's right up here at 1. Sine of pi by 2 is 1. And you can do that for many angles like that. So getting an understanding of the unit circle and understanding of sine and cosine as these coordinates, at least, cosine is the x-coordinate, sine is the y-coordinate, that really helps you with your trigonometry work. Helps you understand some of these basic angles, and as I'm going on to now, it helps you understand where they are positive and where they are negative. And that's very important in the next section we'll be doing in this trigonometry unit on solving trig equations. You need to know where they're positive, where they're negative. How do we do that? Let's look at that now. So let's go back into this is somewhere in the first quadrant. The first quadrant is the first quarter quadrant. It really means quarter of the circle. So anywhere the angle between 0 and pi by 2. So anywhere in there has the same feature, that the cosine, the x-coordinate, anywhere in here is going to be positive, isn't it? Let's go back to 0 and check that out. As we go up, the x-coordinate, it's getting smaller, but it's still positive. And so is the sine. The x are all along here, the sine are all along here, both are positive. So in the first quadrant, sine and cosine of t are both positive. If I take t now into the second quadrant, not that way. Okay, here we are around in the second quadrant now, the second quarter of the circle between pi by 2 and pi. Here's pi by 2, here's pi. Any angle in here, any t in here, will have a cosine, an x-coordinate, that is negative. So anywhere in here, any t that takes you into this quadrant will give you a negative value for the cosine, guaranteed. Whereas, what's the y value in here? Any t that takes you into here will have a y-coordinate that's positive, or 0, but never negative. So in here, sine of t is positive. Into the third quadrant we go. Now, well, the x-coordinate is still negative, isn't it? So in the third quadrant, cos of t is negative, and now also the sine, the y-coordinate is also negative. So both sine and cosine of t, when t takes you into the third quadrant, will be negative. And I'll leave you to think about and work out what happens with the fourth quadrant.